everyone,
go back to
welcome to
the
the
bottom
day
left-hand
3
corner.
of AI 900 quiz, and today
Now
we
we
have
have
with us
two simulation
Santosh
mask
sir,
capture. They
who
are
is,
equal,
the data
exactly the
scientist is
same.
consultant, and he is
So
3x
to change the
Microsoft Azure
size
and
of the
multi-phase
segmentation, right,
personality. So I think that
we
2 days were
select one of
really
the
very
capture
interesting
and
and
we go back
insightful,
to
and
right
similar
top right hand
continues
corner
for
of
the
the
day
stack.
3 as well. And don't
Yeah,
forget
it's a
that
bit
we have a
annoying, I
quiz
know,
for
that you have to
all
go
of
left
you
and right,
tomorrow on the Discord,
but you'll
where
get used to it as
top
you
3
use the program.
performers will be getting the
So
Microsoft
to change the
swags.
size,
So
all you have to do is
just
to change
have
the
happy
mask
learning,
size.
and then you can revise the topics. So without
So
any delay, let's start
if you
with the
notice,
session. So
So what we have seen yesterday, we'll show you the demo first, whatever we have. So this is how the designer looks like. It is still called Azure Machine Learning Studio, but the technical term for it is Azure Machine Learning, where you do all these three things, right? Only the designer is called the designer, but the naming convention has changed a bit. So just get used to it. So what you do in the first place is you need to have a data set, but if you don't have a data set, there are already existing data sets that you can use. Uh, so you can also do it from local file, data store, some web file, or from any open source data sets. So what we are interested in is looking at designer point of view. So how a designer can be used to kind of leverage no code, right? So you don't have to write any piece of line or any piece of code to make this machine learning model work. So this is how the designer looks like. So what are the things that we are doing? So what we initially do is we do have a, database or a what do you have, columns and values, right? So we do have a CSV file, of course. Let's look at the data. For some reason, okay, I do have a trained model, so I can show you that. I just trained it just before 30 minutes or so. Not exactly sure when the data set is not showing up. Anyway, so there is a data set that you can see the columns and values. So what we have here is the entire designer. So from the start, so this is the raw input that you have. So once we go to the so we do have sample data sets that you can use. You don't have to import anything. So we do have a lot of data sets that you can use, movie rating with a data set. So just drag and drop it over here, and then you would have that data set with you. So let's see if at least this shows up. Very strange. Okay, whatever. So what you do is you just drag and drop whatever the data set that you have, what you want, load it out first in the data sets area. Then you can have this data set loaded. So whatever the data sets that you have loaded, like custom loaded, you would find it here. You can again drag and drop stuff. So what we again do after picking out this columns and values, right? So what we do. So these are the columns that you are picking. For instance, this data set is not visible. So what we do is we select all columns, we exclude this column, right? So this is the settings that we have. So you can customize settings, or you can have some comments on half the data set, what you're doing at this particular step. So this could be put into some context so that you can really have some kind of a context where if you're coming to this after a long time, you're unclear what this step does, then you have to have a comment on what this step is doing. Great. So what we do is we select some steps. So let's say what we have yesterday is just two values, x and y. So let's say we are excluding few columns which are not needed for this. So what we do here is some kind of a data cleaning work. So what we do is we clear out missing. So what we have is, um, again, the data set is not available. I can't show you anything. Okay, let's see, at least this one loads once. Hmm, okay. So I think we don't show anymore, I guess. So they don't like show explicit model outputs. I'm not sure why they are doing it. So usually what happens is you see all the columns and values over here. So which one I'm using? At the moment, crazy. I don't think this is not good looking. I don't think you can understand in JSON format. Okay, cool. So what we would have usually is what we had yesterday. It's considered the x and y that we had, right? So the x columns and y values. We pick some columns and we remove some columns. So and let's say if there is a field missing, right? So if the x value is missing or the y value is missing in a particular row, we remove the entire row, right? They remove the entire complete row. Since it doesn't make sense, right? You don't have any temperature value and um, you just have this particular number, so that doesn't even make sense, right? So that is one way of removing the entire stuff. So whatever you have, just discard uh, that particular complete row. So even if you don't have y value, there's no more useful data for training, so you discard both. So these are some of the thresholds that you can have. Again, comments are something that you can do. So the important part is yesterday we have seen like train and test split. So that is the same that we have here. Fraction of rows to be in the data set, 70% we are splitting. I think we have split it yesterday. So the split depends on the data set and how much you want to train the model in the right way. So this doesn't mean that you can train it with 90 and 90 percentage of data set and 10 percentage of your 10 percentage of the data with just test, right? So you can't have 90 percentage training and 10 percentage test. So the problem is it kind of overfits to after some extent, right? So once it overfits, then it is difficult to get it in the right path. So it should be generic. should be as generic as possible, but it should be generic with the model that we are that output that we are expecting. So that is something that we should be really careful on. But the value can be tweaked. It is not that you can't do with 90 percentage 9 and 1, right? So it's considered in layman terms 9 and 1. It is obvious that I have used 80-20, right? So 80-20 is a good split, but 70-30 is a even more good split if you are training with some kind of compute that I'm going to show you. So you can run this in a cluster, so it is not just your local machine that is running, but the complete thing is running on cluster. So you can use how much ever compute that you want. I'll just show you. I have just created compute instance which costs around $0.08 per hour. So that is running right now. So again, we are using the linear regression. Again, I don't see any outputs or anything of that sort. I do have a completed one, so at least. So this is the same pipeline that we are seeing here, the same one, but this one is already it has submitted, so it is asking me to resubmit this entire stuff. So what we do is we again split, and then what we do is train the model. So I hope at least we have some kind of a output. Okay, we have a text file. It's not useful in any way. So it also runs a Python script. As you can see, it is not just some magic coming in. So what this step does, it's kind of runs the Python code underneath. Right? Obvious that whatever the model that you're selecting, and then it kind of generates. They have a generic script, the generic module which has a generic scoring and all these, and then it kind of runs that. Great. You can also see how much time it has took. So this is another part where we kind of score the model. I think we will have some kind of a metrics over here. So we do have the data sets, but I'm not sure why we can't just view it. So usually it happens. Not sure if it has changed just now or my system is not working for some reason. Fine then. So the data set, I think I should have had some metrics or something that shows. So we do also have some previews of the what it shows is they are building something, they are working on something with these tabs. So that is one thing. And evaluation of the model is kind of where you decide the accuracy and stuff. So at least we do have some numbers over here. So charts of the table, whatever you like, you can choose. So what we have over here is to understand this metric. So why we have the closer to zero, the value it is. The model, what we know from the classification model is we know that if this image is a dog or this image is a cat, we as a human we know that this part is this, but you can't visualize this part, right? Again, the data set is not available, so you can't visualize a line, right? So the line that you so let's use this one. So this line over here, the regression line, you can't just you can't just plot it, right? You have like 10,000 rows of data. You can just plot something out of it, but you can do it. But the scale has to be reduced so that you can understand what is going on. But it is hard to do it. So that is why we have a different metrics to measure how close it is to the actual value, right? So if say this is the actual value, this is the dotted value is the value that the model has predicted, and the solid line, I can expand it a lot. So this is the dotted line that we have is um, the model prediction, and the solid line is the model trained. So whatever the model is trained for it, or whatever the fit of the model, that is the line that we have. We have seen the yesterday's line, the regression line, how it goes, right? So let's say how far. So we can't just have some kind of an accuracy, right? So we can't say that this is this much accurate. We are not sure, and why how much accurate it is. We are not sure. This line change? Yes, it will. Once you retrain the model, or once you feed in more data, this line might move up or down. That might vary. So what happens, what we calculate on this particular, since we don't have any other metrics to calculate how far or how good the model is, what we try to do is we try to find the distance between this solid line, right? So this solid point of the same, what do you call, the same axis, right? So we just come down in the same axis in the same path. Whatever the line, whatever the point it is, the x and y coordinates, match it with. It is like basic, difference between 2 points, right? So you do have formula root of x, x2 minus x1, or some formula that I don't remember exactly. I think y2 minus y1 plus something, the whole square. So there is a formula to measure a distance. So you don't need to remember all these formulas. If you want, you can definitely do it. So that is what this represents. There are a few more values to it. So it is not just the um, root mean squared error, but there are other places what you use. So they have different formulas to calculate and compute this, how far this model is getting trained. I think this would be the easiest one. RMS is something that people use a lot when it is a regression type of a problem, that you can definitely try. So what I'll just show you is, so what you need apart from designer, right? So what you need apart from, so what you need is a compute instance. So we do have three, right? So one is the just the compute instance. You just get one CPU, I guess, and this is a compute cluster. Compute cluster is have where you have 10 machines. I think you can also choose the number of machines, I guess. You have to create one, but I do have one. So this is the basic one. So 0.08 dollars per hour. So it would cost. You have like a 4 GB RAM machine, two CPU, and 16 GB storage. So my CPU is 6 cores and 16 GB of RAM. So it is obvious that it is the cheapest one that I could find. Uh, let's see. So this is the place where you select the compute, right? So this is the cheapest one that I could find. So when you go to the all options, and when you filter, it goes, let's see GPU. What is the max that Microsoft can offer? So for if it is not enough, so you can always raise a code. So if you're a company, if you want something for your company usage, you can definitely reach out to Microsoft directly. You would get a dedicated machine. It's not shared by anyone. So you have a VM, which is or a virtual. The entire compute is given just to you. They don't share. They don't split the compute with anyone else. So that is another option. I'll just show you right now. Once we see the maximum code. So $13, 24 cores, 448 GB of RAM. So pretty nice, I would say. I think these people are not populated. So 48 cores, I think it is the max. I think there are hundreds, but I don't think they are showing it. They are showing everything. So even CPU side, if you don't want, what I found is the F1 that I think is the free one. This is the really basic one. I'm not okay. This one. This one is the really cheapest one, right? 0.08. I think this is the cheapest one I could find, which you can spin up and try your testing, right? So whatever I have, the previous run that I did was just this, the low tier model. So whatever, whenever the model thing runs, so yeah, I think it has run for. You go to the steps, you will see what is the duration, right? 2 5. Just count. Okay, let's consider 10 minutes, right? So 10 minutes of compute of a simple model which is already there with a simple data set. So let's consider we have 10,000 rows since we don't still see the rows for some reason. Not sure. This is where you see a table and then you see the columns and values, but for some reason it is not showing. I'm not sure if it is not supporting um, Firefox. I have to use Edge to kind of make sure that shows up. Not sure. Again, what we have seen is you have the starting of it. So what is a data set? You just split of what you want, right? Which column that you want to select, and what you do is do some kind of cleaning work. So this would be a category of work, right? So if it is in a, if you don't know about this entire, Azure giving you this particular designer. So what a normal team would do is they would have a person who kind of collects the data from some endpoint, right, from some website or any place that they want to, and then they would clean. There's a person or the department for doing the cleaning analysis and ingesting the data into the database. That is a part of a data engineer work, and then you will have another engineer to clean the data. So that might also be a part of the data engineer work, validating and storing it in a database, or else you do it later. So ETL and ELT, so validation can be done later, or the transformation can be done later. If there is a date format that your company uses or all your system uses, then you can either port it out in a generic way, then you can format the date in your convenient way of your system, how your system functions, or you can just ingest the data. Whatever coming into my system should be in this format, so you can do it in either way. So this, until this part, your data engineer work would be, and then the data scientist, what he or she would do is they would see the data and try to understand what it does and what we can do with it, whether for this use case, whether this data set is valid, or do we have all the necessary things to do it. So all these validations and things are done, and obviously he can also take care of the ML engineer work someone is asking about yesterday. But if there is no dedicated machine learning engineer, then this part, these two areas would be covered by the data scientist itself. So they would, try to kind of do the entire stuff. If it is a small scale company, then mostly they would be doing it, and the entire evaluation. And another aspect of this is you could retrain the model whenever you want, right? So you just hit resubmit. It is just asking for me what is the experiment that you want to choose and what is the job description, right? So just click on hit submit, and then there is another pipeline running. So I'll just go to the pipelines and see whether there's something else running, right? So the duration is 8 minutes, 8 minutes and 16 seconds. So this is something that you can run and see for everything that you have a, you can create an endpoint to see, publish the entire pipeline, right? So whatever you want, if there's another system which monitors this particular pipeline and how much they are doing, then you can definitely see what is really happening. Not sure why it has completed that fast. It has never ran in the first place. If you don't change anything, I don't think it is running. I think it is giving this run reuses the output from a previous run. So if you don't change anything and if you rerun the stuff, Microsoft is smart enough to tell you that no, there has nothing been changed. So I'm using the same result from the previous run. So that's nice. So if you accidentally resubmit stuff, 8 minutes is not a big deal, right? $0.08 is not a big deal, at least while we are doing it for free. But let's say if the model is running for 10 hours, obviously you can stop it. But let's say if you accidentally start and you are not aware of that, you just accidentally click it some way, and then you go out and come back tomorrow. Then if the model is running and it costs you an extra, right? So that is something that you can be mindful of while you're dealing with Azure. So make sure what I will do is once this session is over by 7, I'll try to delete whatever the resources that I've used. Right? So demo AI 900 would be deleted from my entire report. Right. So when I want, I just spin up another one and show you guys the demo. Right. So I have never ran before. So I just started this trading at 5. So just want to show you how this thing really looks. So most people, as I said, in the first day, they don't know, they don't even see the portal, but they have like 3 certifications in the fundamentals area. So that doesn't make even any sense for someone to just see what is really happening. Even we don't have any lot of data to show. Otherwise, here you will show the periodic increase of your model. So if there is two model A and model B, so how good it is, what is the latest value, or how good it has performed, all that you can do. There are new features. I haven't used this. You can also create some charts. So what are the steps, what are the values that you have, you can also definitely do. So this kind of shows you that at which step this has increased, or how much percentage it has increased. So all these things, 5 runs is plotted. So you need 5 different runs. So we just have to. So these are something that you can definitely explore. So what you have to do is you have to use it and then you have to delete it. Right. So that is something really important. Even if you go to the Microsoft Docs, they highly recommend that they would be a dedicated step at the end of the documentation stating how to clear your resources, since it doesn't want, they don't want to for them to pay for something that you are just having it, right? So if you have a VM running, then it kind of costs you a lot, and it is a waste of compute for Azure as well. So it is waste of electricity, the power that we are getting, right? So what they try to do, they try to have a threshold. So for Azure functions, we have like a 10 minutes threshold. So if the endpoint doesn't receive any request, what it does is it shuts down all the servers, all the compute that is being utilized for the Azure function. So if you have like 1 hour of duration, then you come back and you will have no servers or no compute running for your Azure function. So what happens is if you can just give a request after 1 hour, it would take at least 3 minutes to give you the output. Why? Because there is nothing running to serve your request. Right? So they shut down everything. So the initial request comes in, and then they provision a compute, and then they put your code into it. They start running it. So that is how it starts. So once it starts, then you can hit it with 100, 200 requests. It would give you the output maybe in some milliseconds, or at least in 1 or 2 seconds, so at the max. So that is how this works. So make sure you kind of delete or free up all the resources that you have used once you're done with your demo, or once you're done with your experimentation and all that. So what we will do now is we'll again go back to our slides. We have to share it once again. So if you have any questions, put it in the chat and just start the slides. So this is pretty interesting to see. As I said yesterday, we do have
mentioned in here
Hello,
is
sir. I
e-commerce.
think.
Everyone of you must have heard about
Hello.
Lenskart, where
Yep.
we can see this.
And now
Can
I
you?
think we can see the slides.
This is also one form of AI in which
Yeah,
we are
we can hear
augmenting
you,
the
sir. We can
spectacles
continue
on
with the
us.
session, sir.
Yeah, yeah. So what happens here is we'll try to understand the image part as we have discussed yesterday, how that image thing works, how you have an image. So we'll talk about most of the things that is out there for the subjective, but we'll try to understand what exactly they are. Great. So the first thing that you see as an image, right? So any image that you see anywhere, maybe on your mobile that you are seeing, or maybe the place that where you are looking at through some kind of a representation that you get from an image, whatever the image that you see from any place that you see, right? It is consisting of some random pixel values, right? So you can generate a random image if you want to. There are few ways that you can just to have some pixel values, just throw it out, and then you will have like a image to see, but this it won't be this sharp, right? So this sharp, and it won't be of this sort as well, but at least to some extent that you can see how the image looks like. So this is something is really fascinating to see how it kind of creates this color, right? So these are some random pixel values. So, uh, can you put it in the comments? So, how do you think that images actually are, or how you see an image of this kind? Once you have it like segmented, all the segments is there that you can see. Uh, the values that you see obviously ranges from 0 to 255. The every pixel has some kind of an intensity with it, where it can go up to that level, right? So if it is a black and white image where don't have any colors at all, you just see white and black. So we do have old age movies and other stuff where you just see the black and white pixels, so you don't see any color pixels. So what is really fascinating to see is what we have on the grayscale factor is the same for the colors. So colors comes from three different layers, red, green, and blue. So what we try to do is we embed all these three layers on top of, or we just remove the entire black and white layer, the grayscale layer, and then we replace that with all these three different layers, right? So all these green, red, green, and blue. So what happens is if you tweak all these three values, then you get all the colors that you see in a particular image, right? So that is something that we as a at least to see what is happening, at least half the images formed in the first place, that is something is really fascinating. Even if you just go in front of your monitor right now if you are having a uh, obviously you will have a 1080p monitor. If you're using your laptop, it is obviously visible. Just try to move a lot closer with a random image or the YouTube stream that you're seeing. If you just move a lot closer, what you see is the pixels inside the screen, right? So all the things that you see as a digital form, as a single entity, as a single screen is a ton of pixels. To be exact, 1920 cross 1080. So that is the number of pixels that you have for a 1080p screen. That is your full HD screen, and for high definition you have 720. Okay, so that is the max that you can get. Now we have 4K panels even for laptops, and you have 8K TVs. So that is, you can just multiply that number. I'm not sure on the numbers for 8K, but again there is a number which you can calculate, and you can multiply that to get the total number of pixels in a particular image. So for this image, let's say most of the images that you would train with the machine learning model would be around 100 pixels or 200 pixels or 300 pixels, 300 cross 300 or 100 cross 100, 24 cross 24 is the basic image. So you would see the real pixel thing. You won't see the entire image, but you'll see the pixel aspect of it. But once you get into deeper into building models for real-time use cases such as this, so what we have is an application side of it. So I'll tell you how this started, right? So what are the things that we as a humans have done with this image recognition or with just an image, right? So as an image, what you see here is just classification part of it. So you don't have anything else apart from the classification is classification done. Right? So you don't have anything at all. You just tell that this is an image, try to classify it, and tell label this as a taxi or a car or whatever, or a SUV, whatever you call it. So all these terms matches with the particular uh, single object, right? So we do just see one car, right? So we just see one thing, and then we recognize that this is something that is good for particular use case. Maybe if you want to recognize, you take 100 images in your phone, and you want to say that I went for this particular trip, and then I have to sort it by whatever the images that I am in, right? So Google Photos has that feature where you can just click on your name, and it kind of sorts out the images that you are in, right? So that is pretty nice. And you can also sort with your vehicle and all your maybe if you're having a watch which is really new, and then you want to classify that, or whatever the images that has a watch, you want that particular image collection. Those are the applications of just an image classification, right? So you don't do anything else, you just classify that image. So what we try to do apart from that, right? So what we try to manifest into the image classification. So this image doesn't have only a car, right? So we do have pillars, we do have a wall, we do have trash cans, and then we have a person. So I'm not sure if you can see it, but there's a person walking with a hat and wearing something in black, right? So what happens here is we don't care about all these, right? So as a human, we do see all these things. We do have a sign, we do have a board, we do have a board on top of the taxi, on top of the car per se. So we don't eventually know, or we don't care about all these features. Then what we evolved is we just give this model, let's say I want to classify all the objects, whatever the objects that they are inside an image. This is really fascinating that how far we have moved in as a image recognition or classification stuff, but we want to do more with it. We just don't want to give a single image and ask it to classify that every human can do. So what we try to do is we again try to classify the objects that are present in the image. So the next step or the next phase of what we have done as a organization, or what we have done as a community, is we try to find the spots or find the areas that it has recognized. So let's say if this has to be a car, right? So this has to be a car. What are the pixels that are needed to make this car as a car, right? So this obviously maybe 300 to 400, since it is a rectangle. So obviously this would be somewhere around that. Let's consider 300 cross 400, right? So in this 300, we do also have a bounding box, and this model says that this is where something lies. We are not sure. Let's say forget about this is a car, but this tells you that this is a box, and there is something inside this box, and I have recognized that as this. So that is all this thing gives you, or that is all it tells you about the particular image. This is a car, and this is a bus, and these are cyclists and people. Maybe this has a sign, trees. So they have missed out on all these. You can also have some kind of a sign over here, right? So the signs on the road, that could be something, and this is something that you can definitely do as part of your work, right? So it is not just what you see over here, but you can definitely see other things, right? We do also have a tree and we do have a crosswalk and all that. And this could be cyclist or this could be people, and how you train it would describe that person, or it describes as them as cyclist. So we don't want to again step further. We don't want to just have a bounding box telling me that this is the place that something lies. So what we try to do is we always try to push further. So if someone is working for us, what we try to do is you try to utilize them the most, right? So that is the human nature of how we deal with things. So what we try to do is we try to find out the exact pixels that is helping to form this particular uh, person or an object. So what we have done is we try to find the exact pixels, but this is not exact, right? So it has some deviation. So you would have the lamp over here, but there are few um, plots of the blue color spread across. I hope my cursor is visible. Yep. So what happens here is we do have some deviations. So this is also not perfect. So we do have, we could have crossed of this size, and we could also crop it till here, right? So till here we could have cropped it. But the thing to understand is, at least for this image, it is fine to have some kind of deviations. But for this recognition, like an exact copy of it, so if you just copy that particular pixels and you enlarge it, and you will get that particular object as a whole, right? So that is some segmentation stuff happening, where you identify pixels rather than group of pixels. So you identify each and every individual pixels that forms some object. It is not just a car. You do also have a bus. So we do also have people over here, right? Since this image is not clear, we don't see that, but we can clearly see we do have people over here, and there's another person walking. So it totally depends on how you have trained it. And as I said again, we don't want to just have some kind of random work done. So what we try to push it further again. So what we have done again is we try to understand the image with NLP, right? Natural language processing. What we try to do is we have an image, just give this an image. There could be a lot of descriptions for an image, right? So it is not just a person with a dog on a street, right? So it is a somewhat okayish, analysis. So you can also see, it is a traffic-free road with the person and the dog, right? So he's obviously walking, or he's holding a mobile phone. And you can also talk about the dog breed, and you can also talk about the signals that it is red, so he can walk. So all that is something that you can definitely point it out. It is totally based on how you train the model. So there are two aspects to it. So one is the image recognition. So what are the objects that this image has? So there is a person, there is a dog, this is a street, and we do have three cars, four cars. If you count one behind his hand, and we do have trash cans again. We do have buildings, glass windows. What else we have? We do have a huge, uh, uh, 50 or 60-story building. So all these are there inside image. What we are interested in is there is a person and there is a dog on the street, right? So this is all this classification gives you. So this image classification would give you there is a street, taxi, there's a building, there's a person, there's a dog. So what the NLP work is to extract all that and put it into a context. So it can't just tell person, dog, street. It would be really annoying to see a model doing that. So it is not a right way of training a model. So you can't just have all the words spread across to make a sentence. So you should have a proper sentencing done. So this is something is really good. And again, this is something we have done a lot. So once you push the boundaries to some extent, you can't just go further, but there is possibility. So what if I tell you that I can just use this image and make a video out of it? So just take this particular image, right? So this particular image, I can make it into a 3D image. So how cool it would be to make this particular single image. So you just give me a single image of any building or any place, and I can make a video or a 3D visual thing that you can walk through. So all you can see is the virtual reality where you can just swipe across the entire 360-degree view. You can see down, up the ceiling. You can just zoom in, all that. So that is something that NVIDIA is working on. I have seen some couple of that in the LinkedIn feed. So that is something that really fascinates about how much image you can do, and that is how people are trying to push it more and more, right? So you don't stop with something, right? So once we have invented steam engines, we don't want to we didn't stop there, right? So we do have electric cars now. So we didn't stop with, let's say if this is fulfilled, everything is running on steam, all the boat engines, all your railway tracks and trains are running on steam, all your cars and other things are powered with steam. It was good to some extent, right? So how you power the steam is another area to talk about. But again, how you have evolved from there. We didn't stop at that particular point once your use case is solved. So my use case is solved, why should I innovate? So that is not what we do as a human or as a community, for at least as a developers. And the final thing to talk about is the OCR. So OCR is, pretty much it is an older way of describing it. It has been here for a long time, and this is something not really new to us and how we see stuff. So this is something that we have seen a lot of places happening. When you take a photo of something, and you obviously have some kind of a response to it. If it is a printed text, as we see, printed text is easily recognizable. All the fonts that you have, it is easily recognizable. For others, it is really hard to recognize. So your handwriting stuff, my handwriting is really, I can write really good and really bad. So if you train a model and give it to me, I'll write a really bad stuff in the means of handwriting, right? So when you write faster, you would scribble a lot, right? So you can't even read once it is like a 2 day or 3 day, right? Once you take notes of something really fast, and then you come up to after a week or three, and then you see the text and you can't even recognize what they have written. Whereas if the context is gone, if the context, let's say you are attending a workshop of, let's say you're attending this workshop and you're trying to take notes faster, without knowing that this is a live, it would be taken down, it would be recorded, it will always be there. But just in case if you don't know that and you're trying to write down stuff faster, and then if there is an exam that you're taking here and you want to refer, there was a boot camp that I attended from Santosh, I'm searching for that, where it is, and if you take that and recap without the context of me having to tell all these things, then you wouldn't have any of the understanding. So that is really hard for a model to do, but there are sophisticated ways of doing it, right? There are models which can do it, but it's a bit harder than your printed text. You can find all the printed text, you can generate printed text for recognition. So for everything that it is out there, you need data that has to be that is driving all these machine learning. So another part that I missed out in the history of why now, why machine learning is now, and why we are creating and focusing on the models now, is you have abundant of data. So Google Photos is one of the largest collection of data sets that Google has, right? So whatever they do, they use your image. Even if they say no, they definitely do. It is obviously there. They have changed their terms and conditions for many times, right? So you just go to their page, see how far they have changed. It is the same case with WhatsApp. Whatever the terms and conditions they have, they change it up every 3 months or 4 months. This is the case for everything. They need data to for everything. Feeding the model is something like where you buy a Lamborghini, then you have to pump it every time. So every maybe 20, 30, or 100 kilometers that you drive, you have to feed in petrol in liters, right? So 50, 60, 70 liters that you have to put through, so that you can go for a long ride. So that is how much the model consumes. So the more the data is, the more accurate the model gets, right? So before 5 years, if you see, I'll just stop with this, then we have like a feedback time. So maybe before 5 years, have you have seen the translate? Google Translate works is it would translate the text as such, right? If let's say a person with a dog on a street would translate text by word, translation is all that it can do. A person, it would translate in a different language. The dog, it would translate in a different language, maybe Hindi or Tamil or whatever the language it is. For Indian languages, they didn't have even anything, I guess, before. I'm just saying, 5 years back, once you use translate, I'm not sure even if translate existed, I guess. I have seen where it kind of translate text by text or word by word. So every word it translates to a different language. But now, if you kind of even put out the slang words, it kind of gives you the right bit of translation to the another language. So just try it out. Just go Google or Bing, Google Translate, and try to type something or whatever the text that you have sent to your friend, and then try to see if that is converted in the right way. Even that gives you an English version of all your Hindi text, right? So all your Tamil text or all your Telugu and all the languages, you get an English version of it, right? So that is really cool that at least they are that they have done, right? So it is easy to understand for someone who is from a if their mother tongue is not that and they know English pretty well, so they can at least read that to sound like to talk, right? If you want to ask something and if you don't know Hindi, and then you type whatever language that you know, and then you get the Hindi text in English, right? The English version of it, and then you at least try to read that and make up something that that guy would understand, right? So if you're going for if you're buying something in a shop or something, if you want to translate that, that is something useful. So that is all I wanted to cover for this bit. And this is the time where you can shout out all your feedbacks and comments, whatever you have. You don't have to fill out with your personal email ID if you don't want to. There is a anonymous thing that you can do. Just go to this link or scan this on your mobile. Just type it out, or I can also put it in the chat if you want to. I think it is easier to type. So Bitly ADC is Azure Developer Community, AI 900, and this is a second bootcamp. So just go there, fill out the form. If you want to ask something, this is the right time to do. We do have 5 more minutes. So if you have anything to ask or anything to clarify, you can definitely do it now.
Yeah, so I do have one question. Like, so Santosh, can we run Jupyter Notebook on a free, free student benefits with the student benefits? If we have a student benefits account, and can we run the Jupyter Notebook over there? Because when I was trying to do it yesterday, it was not running because I was not able to select the. It was saying when I was connecting the compute, I was not able to select the machine that I want to select. So, uh, what
I think
are
we
your
have
views about this?
Okay, we did talk about this compute thing. It costs a lot to run, but I would prefer if you don't want to use Azure, you want to just try out stuff, not the designer, but you want to focus on building something, you can use Kaggle. So you have like a 30 hour of GPU time. You can definitely use that. It is pretty similar to it is. I think it is a direct replica of Jupyter notebooks. If you don't want to use Azure, you can use the Kaggle notebooks. You can just upload your notebook, upload your data set, and then you can start using their compute to train if you just want to do it for free. But as I showed, you need a subscription and you need a compute instance for spinning it up. So it, as I said, it costs around $0.08 per hour if you're running it. So if your model runs for let's say 20 hours, then it kind of you have to multiply that. So, but better if you want to experiment with a designer, then I would highly recommend you go with Azure Machine Learning Designer to call your designing part, put the model, feed it in, just hit run. So you don't have to do anything. But the Jupyter Notebook, the problem with the Kaggle is you have to keep it on always, and you have to do some kind of an activity. So if you don't do it, it kind of stops. So that is something you should be mindful of while you're doing using Kaggle. I think it is 20 minutes or so. If you don't leave it as such and you go back and come, then the notebook would be stopped. So it is like a free compute that they are giving. So they don't want you to kind of run whatever you want or whenever you feel like you want. So what they do have like a limit cap. So that is something that you can definitely leverage. But for this, you need to have a valid subscription and you have to definitely pay for it. So that is the only disadvantage of using it. It's not like a disadvantage, but it is not difficult for a student to get have a credit card, and it won't cost you a lot. It might be 10 rupees or 20 rupees a month. If you have like a compute which is running, you won't run it for hour, right? So as we have the previous thing that I told, it was running for 8 minutes. So it won't cost you a lot, maybe 20 or 30 rupees per month. If you are shutting down on time, let's say you are using it for 2 hours, 3 hours, you work on some prototype and then you shut it down, then I think it won't cost you anything. It would be zero on your credit card. When you want to pay something, it would be zero, of course. But you should be mindful of when you have to complete it. You try to shut it down and use other resources which is free.
Yeah, okay, that's a perfect answer. So that's why I was confused about why I'm not able to select the, because yeah, this is the right answer. So thank you for giving clearing the doubt. So if anyone has any doubts, you can just drop down in the comment section. Otherwise, we can wrap up this bootcamp right now. And guys, we will be having a quiz for you all on the bootcamp that Santosh has covered. The syllabus he has covered on AI 900. And if for getting the certifications, certification vouchers, you can join our Discord server link. Let me share it. So it's bit lead is a Discord. Discord. So you can just join Discord server link, and yeah, so you can just join Discord server link, and there is a channel hashtag AZ certification. Go over there. You have to perform certain steps. You have to put in your LinkedIn profile. You have to put Microsoft Azure certificate, Azure as your skill, and then you will have to put your LinkedIn profile into one form. So complete all those steps. Everything is mentioned there. Even for your reference, there is a video. So complete all those steps, and you will get your certification voucher in an week. Okay. So thank you guys. Thank you for joining in. Okay. So when we have one question, is data science just a
Okay.
hype that will die down and slowly become a part of daily role of software engineering?
Okay, pretty interesting one, I would say. It won't be just it is like a role of software engineer is a pretty generic term. So now if you see as a software engineer, everybody does the same role, right? When you see 10 years back, everybody is called. There is no good role of data engineer. Even if you are downloading file from an FTP server and then dumping it into a database, you will be still called a software engineer. So this naming convention has changed, but software engineer is a pretty generic term. So you have to classify yourself as a full stack. Even in full stack, they would call them as full stack, but the role exactly what they're working inside a project would be on backend. They would be working on Node, they would be working on Express, or they would be focusing on the React side. So even if they are called full stack engineers, again it goes for data scientists as well. So in smaller companies, data scientist is a huge role where you have to do the end to end, right? So you start from the data fetching till model deployment, a data scientist would do. But obviously, in larger corporates such as Google, Microsoft, and all that, data scientist again a generic term for them. You do have ML engineers, we do have data engineers for feeding, we have ML ops for deploying it and monitoring it. So you have different roles inside a single. This role can be split up. Data scientist role has been split up into all these three. Data engineer would do the data validation cleaning part, and then you will also have these ML engineers specifically training the model and deploying it. We have the ML ops, so the machine learning. You have DevOps. It is similar to MLOps where you deploy the model and you try to monitor it. You have the metrics, you measure it. So this is a generic term, and it is not like a hype. It is a different branch of. It won't be becoming a software developer role, right? So software developer again, it is a pretty generic, and it won't die anyway, right? You would have something to build upon. As I said, how we have evolved in all these image classification. We just came from image classification to face recognition. So that is how it goes. And as I said, 3D from an image, so that is something pretty cool that you can expect to maybe rolling out to everyone out there, maybe in a year or so. Everybody will be doing that. Take a snap of any location and then you will have a 3D view of the entire location. If you have missed out maybe in a different, if you're visiting some monument and you missed out taking a picture of something, and the AI can generate that particular piece to you. So that is something cool that I'm expecting to roll out in maybe a year or so.
Yeah, so that's the real honest answer. So Anand, you won't be getting any best answer than that. I hope so. Thank you, Santosh. Thank you for coming in. Thank you for joining us for the boot camp. And we really appreciate you gave your time. You gave your, you invested your time in these students facilitating about AI 900. And it was really great having you here. And thank you guys. I hope you got the real insights about AI 900 and what AI looks like and what Microsoft AI looks like in Microsoft Azure. So thank you guys. Thank you for joining in. See you soon. We are Azure Developer Community doing multiple initiatives for Azure. So see you guys. See you then. Bye bye.
See you guys. Take care.